Hello all, welcome to the Abaqus Python YouTube channel, and this is the Abaqus Python Scripting Learn with the Concept lecture series. This is the 10th lecture in this series, and today's topic is create a model. We are going to discuss how we can create the model, build the model, and submit it in the Abaqus CAE, and how we can automate it, create a script. So it's more of a creating a DOE sort of. So before that, all the files that I'm going to use it in this lecture, including Python scripts, explanation PPT, all these you can find it on this GitHub link. So you go and check it out. So there are two things in the analysis usually. One is the pre-processing, which is the today's topic of discussion. So creating a model, assigning the properties, doing the meshing, applying the loads, boundary conditions, and all those stuffs, right? And then we have the post-processing, which is the seeing the results, what it means, getting the meaningful insights from it. So there are two aspects of the analysis, right? So today we are going to discuss the first part of the analysis, which is the pre-processing, right? So in this today's discussion, we are going to consider this simple block with a whole model. Very simple model, but the intention is not to teach you the how to do the analysis, but how to develop a script which can create a model and submit on its own. So in this model, you can see there are four parameters we have on the dimension side: length, width, and the height. So all I'm considering as 20 mm, and the radius of the hole is 6 mm, and the pressure that is going to get applied on the top surface, which is the pressure P. So we have five parameters in total, and these parameters we are going to create a variable, and so that we can use these variables, we can change this variable and run different models with different values. So this is more like a DOE kind of a study. DOE stands for the design of experiments, wherein you change certain parameters required for the analysis, and find out which combinations is the most desired one or the optimized one. So those kind of things we can do once we build the script to do the analysis, right? So what things we have to consider while doing this? There are multiple steps involved in this pre-processing, that is when we want to build the model. So one is the creating a part is nothing but a blueprint. I may have discussed this already. So there are multiple ways how you can create a part. So these are the individual components in the assembly you can consider. Then these parts needs to be assigned certain kinds of property which are required to simulate particular behavior. Then we have to kind of assemble these parts, but as our model is very simple, we don't need to do extensive assembling here. But that is how the Abaqus convention is, so we have to do the assembly. Then we have to define what kind of analysis we want to do. So static, dynamic, or visco, which is quasi static, or the coupled kind of analysis, those we have to define it here. Then we have to define what kind of loads you are applying, and where all the places where you are constraining your model. And then at the end we have to mesh the model, this so basically discretizing the model. And once we do all these steps, right, we can submit our model. So we will create a script including all these six steps, and we will create a script in a way that we can feed in some parameters to this script, and we'll get all the information or all the combinations of analysis, right? So let's move to the Abaqus
So
CA
here
and
I
get
have
started.
opened the Abaqus CAE, and here we will going through part module, property module, assembly module, step, load, mesh, and job. So this module we will cover it today, and using these modules we'll create a script. And the way we are going to create the script is very straightforward. We have discussed this multiple times in previously in our lecture series. So we will create a model in the Abaqus CAE, and as you know, the commands will be recorded in the replay file, and those commands we are going to use it to create our final script. So before that, we have to do one very important thing, which is changing some default journaling option. Okay, so why we have to do that? While creating a script, I will tell you, but before, we have to write session, then we have to write journal options, then we have to say set values, basically means changing the values or updating the values. Okay, now let's move on and create a part. Click on the part, create a part, and here write, let's say, block. So my part name is block, and which is of 3D type, because a cube is a 3D or block is a 3D. And the feature, the base feature, right, we are going to create a solid shape and from the extrusion. So in this case we have to create a sketch, so 2D sketch, and the it will be extruded in the third direction. So we'll create a simple rectangular first. So minus 10 comma minus 10, which is lower left, and the upper will be 10 comma 10. And then we'll draw a circle which has the center at 0 0, and the one point on the parameter we have to give, which is 0 comma 6. That means the radius of the circle is 6. Now this is done. Now we just need to extrude this thing, and the depth we are going to give it as 20, right? So this model is created. Now we will directly move to the property. First we have to create a property, then we have to create a section which has this property, and once we create a section, then we have to assign it to the actual part that we have created here. So let's create a property here. Let me give the name as steel, mechanical, elastic. Here the properties are 207 gigapascal, so I need to put it in megapascal. Now I have created a property, I need to create a section. So solid section, homogeneous, click continue. Properties are material properties already selected, click OK. The section is created. Now I need to assign it. So while assigning, I need to give some proper name because it will create automatically a set. So I selected the model and click and done. Then select section, click OK. Now you see the color has changed. That means the property is been assigned. Now go to the assembly module, click on create instance, and because there is only one part, I just need to select that, and which is already been selected. So click OK, and that's it. So this is the assembly done, which is very straightforward. Then we have to create a step. Click on this, the give the name as pressure 250 MPa. Then choose the type as static general, click continue. Non-linear geometry option on, initial as zero point 0.2, maximum. These are some default condition we can change. If we don't change, that's also fine, but let us change that. Now we have to create a loads, and what kind of load we are going to create? A pressure load, obviously. Click on continue. Now it will say that select the surface where you want to apply the load. It will create a default surface name, but I don't want that, so let me write load top surf. Click done, and give the value as 250, right? Now create a boundary condition. Select the face, which is bottom. Here write BC bottom surf. Click encaster. That means all 6 degree of freedoms are going to get constrained here, translation as well as rotational. So now loading is applied, constraints are applied. Let's do the meshing. So we have to do the meshing part by part. Obviously assembly level meshing can be possible, but we have chosen part level meshing. So I want to change the global mesh size as 1 because 2 will be very big. So just assign that and hit enter. It will create a automatic mesh. So because this is a very simple model, this meshing is taken care by Abaqus. But if your model is really complicated, then we have to do some extra things. Now just create a job here, and go to the job manager and click on submit. So you see the model has been created, right? And that's all what we need. Let's go and check the replay file and then start creating our script. So I have this replay file open here in the notepad plus plus, and we are going to create the script in the spider. So I have written different sections. Okay, let's move ahead. As we need to set some objects in the viewport to be able to see, we need the viewport object. So let's take these guys. So in the session we have current viewport name method to get the name of the current viewport. So we'll get the current object something like that. So we have to import the session from the Abaqus. So from Abaqus import session, and this viewport we are going to make it current and we want to maximize it. Now here then we will add multiple user inputs as and when those are needed. So we are going to create a model we have not created in the Abaqus CAE. So from the MDB, so from the Abaqus we have to import MDB, and it has one method called model, and it take name as. So let's create a model name variable, and other input it takes is model type, which is going to be standard explicit. So the model name I'm going to define it as block, and this standard explicit we have to import it from Abaqus constants. Okay, now let's move it. So first we have to take sketch, and till it should create a model, and this thing we should take all these things there, and we should create sketch object from the my model. So replace this one with my model. Now this thing we don't need. Now we have to draw rectangle. To draw a rectangle, you see we have these 2 points. So define this as a variable. So here we have to write minus w by 2.0 comma minus h by 2.0. Then in point 2 w by 2.0 and h by 2.0. And then we have to draw a circle, and it needs two inputs, center chord and the radius. Now write, instead of this one, replace this one. Now define a part, which is this. Let's give me the name as my part, and this guy is my model. Let's create a part variable and assign it here. This one we don't need. This one is my part, and we also sketch depth we have to write it here. This is a sketch, and set it to the viewport, and this is going to be my part. So from my model we'll delete sketch. So what variable we have to import? So standalone 3D. So take these guys there, import those guys. Okay, next thing is material. Okay, this is where we defined. So again, this is my model. Then material name variable we will create. Then we will create Young's modulus and Poisson's ratio. Let's use them. Put this guy at the top. Now let's create a section. So from here to here. So this guy is my model. Let's create a variable section name, and this is going to be material name. Then so this is where it will be useful, the line that we have used, right, the journaling option. So instead of using the default methods to select the entities, it will use the very useful method called find at. So because there is only one cell here, so instead of writing using all this information, so when giving the cell information, I just write my part dot cells. So because there is only one cell, so it will give us the array of cells. Now, so I need to create block set name and assign it here. So section name. So instead of this, we'll write. Okay. So these constants we have to import. So importing these constants. Okay.
So this is done, right? Section and assignment is done. Now let's create assembly. So this one is the assembly and instances. So here, so assembly, let me give the name as asm obj. So this is assembly object, and this is going to be my model, and this is going to be viewport, and what we are setting, assembly object. So now instead of writing it here, let's write it after creating an instance. And here the important thing is instance name, which is nothing but this, and it is my part. And there is this one constant we have to import on, and the assembly is done. Now we will go to this step. So where is the step? Here it is. So this is my model, and let me create a step name. Okay, now let's go to the loads and boundary conditions. So it starts from, okay, here model find at surfaces pressure, right? Model starts in caster till here. Let me do the replacing first. That is getting painful. Yeah, that is one thing at least. Okay, instance, from the instance it is finding at this one. So I need to give the coordinates of the top surface. So to do that, I need to go and check where my model is. Okay, my 0 0 is here, so I need to give the coordinates here, which is going to be 0 0.1 hy 2.0 and 0 0.1. So this point should lie on that particular face, then only that face will be selected. So any tiny one point on that face, that's it. And so in the assembly mod object, I'm creating this surface and the name, right? This name is very important. So this is the surface. Now load is okay, create step. So step name I need to write, and I need to import uniform and unset. This I don't need. So this is about that, and now I need to write the same thing for the boundary condition. Instance faces find that. Now similarly I need to write the same thing which is exactly at the bottom. So same thing I can copy, and instead of plus I need to write, that's it. And similarly I need to create a variable for bc bottom surf. Replace step name variable here, replace asm object here. So inputs will be at the top and constants will be imported. Now mesh, so we have to regenerate the assembly as well. So here is the mesh related code, from model till generate, then regenerate. So session commands are not needed, so let's delete them. So we are doing the meshing at the part level, so let's use the part level commands. So for the mesh size, let's define a variable called global mesh size, generate the mesh at the part level, and regenerate the assembly. Now I just need to create a job, that's it. So here is the job related code, job object and job submit. Now let's create job name variable. Model name variable, we already have it. We need to import the constants used here: analysis, single, off, odb, default, percentage. Again, inputs will be at the top and constants will be imported. Just write the job name variable here. So now our script is ready. So let's open a new session of Abaqus and check it. So create a new folder and launch Abaqus in that folder.
Now a new Abacus session has launched. Now run the script.
Okay, so we got an error on line number 40. So keyword error on model type. So let's go and check our script. Oh, so the error is M in model type should be in lowercase rather than in uppercase. Now let's run it again. It will take some time to run, so wait for it. So let's go to the job module and just check our job status. Okay, so our job is running. So the job is completed, and also you can see the results.
Yeah, it's done, right? Okay, so the script is completed. So what you can do is, to further enhance this script, so we have created all these variables. So put all these commands in the function or the class, and then provide these variables through the script text file, and you can do multiple analysis. Yeah, that's all from this lecture. Thank you. So stay safe, be hungry to learn. See you, bye, and tada.